periodic and non-periodic signals. A continuous time signal x of t is said to be periodic with period t if there is a positive non-zero value of t for which x of t plus t equal to x of t for all t. Continuous time signal x of t said to be periodic with the period t. Period t. This is periodic. This periodic. If there is a positive non-zero value, here means positive only will come. We should become no zero. Must of t, which is for all t. For all t. Okay. With 0. An example of such a signal is given by figure 1.3a from 1.7 or figure 1.3a. It follows that x of t plus m t caps T is small t equal to x of t for all t and any integer m. The fundamental period t naught of x of t is the smallest positive value of t for which equation holds. Note that this definition does not work for a constant. Note that these definitions does not work for a constant. Here, figure 1.3 examples of periodic signals. A, P, here x of t continuous time signal. X of t continuous time signal. Here t period t. Here 1 t, this is 1 t, this is 1 t period. Periodic up to this is t times time scale. Okay. X of t continuous signal. Here for all t, for all t, for all t, for all t, any integer m, the fundamental t naught, this is, we can say t naught from here, this is or this is or this is, okay, from here to here, from here to here, here to here, here to here. Note that this definition does not work for constant signal x of t, known as DC signal. DC signal is the constant signal. For a constant signal x of t, the fundamental period is undefined. For a constant signal x of t, the fundamental period is undefined since x of t is periodic for any choice of t, and so there is no smallest positive value. Any continuous time signal which is not periodic is called non-periodic. Any continuous time signal which is not periodic is called non-periodic or aperiodic signal. So here here x of t is said to be x of t is said to be x of t said to be x of t said to be periodic with a period t with a period t. This is t, this is t, period t. Set to periodic with periodic. This is we can say periodic. Okay. If there is positive non-zero t value, positive non-zero t value, positive. Okay. X of t, that is this t, full integer equal to x of t or all t or all t. Okay. Example, such a given signal follows that x of t mt means integer. This is from to here all. That's why empty. Integer, no, full, not half. This is full. People means what? How much coming here? Here. So equal x of t or all t any integer m any integer m in between from to here, from here to here, from here to here, from here to here, here to there, here to here, there, here to there, here to there, like this on. Note that this definition does not work for a constant. Constant will not work. Constant means DC. That's why here x of t known as DC signal. For a constant signal x of t, the fundamental period is undefined, since x of t is a periodic for any choice t, and so there is no smallest positive value. Any continuous time signal which is not periodic called non-periodic or off-periodic signal. Any continuous signal, if any continuous signal is not periodic, then we can say call non-periodic or off-periodic signal. Okay. Periodic discrete time signals are defined analogically. Periodic discrete time signals. Analogically, a sequence discrete time signal x of n is periodic with period n. Is periodic with n. How much distance? Same here, same here, same here, same here. That's why periodic. Periodic with period n. Period n means from here to here 1n. From here to here 1n. 1n. From here to here 1n. 1n. This distance. This is not equal. All are equal. Not plus or minus, increasing, decreasing. Same. Equal. Periodic with period n. If there is a positive integer, that is because this is a positive integer, not any decreasing. So positive integer full, not half, not point something, full. Here 1n means from here to here 1n, from here to here 1n, from here to there 1n, here to here 1, so on. If there is a positive integer n for which there is a positive integer x of n, small n plus caps n equal to x of n for all n. For all n means this. Okay, this one x of n. So total x of n. Okay. An example of such a sequence is given 1.3b. 1.3b. From equation 1.9, figure under 1.3b, it follows that x of n plus m n equal to x of n. This equation for these signals equation, this is the equation, x of n equal to plus m n equal to x of n for all n, for all n, okay, all n, and any integer m, any integer, this is one n, this is integer 1, it means 2n, all are equal to here, sorry 1n, this 1n, this is integer, then period, same value from here to here to there, this is same value, that's a period. The fundamental period is n naught of x of n is the smallest positive integer n, for which equation 1.9 holds. Any sequence which is not periodic is called a non-periodic or aperiodic signal. Same like continuous signal. If any sequence which is not periodic means what got here? Same like this. This is periodic. If it is not periodic, that one aperiodic. Okay. Note that a sequence obtained by uniform sampling. Note that a sequence obtained by uniform sampling of periodic continuous time signal may not be periodic. Note also that the sum of two continuous time periodic signals may not be periodic, but that the sum of two periodic sequences are always periodic. It means, note that a sequence obtained by uniform sampling. This is uniform sampling. Here to here. Same time. Time is the same, uniform sampling. That's why here telling uniform sampling of a periodic continuous time signal if may not be periodic. Note that also that sum of two continuous period signals, may not be periodic. It is not a must. All that the sum of continuous periodic signals may not be periodic, but the sum of two periodic sequence, two periodic sequence is always periodic. Okay. Same what is here? Same sampling time also same. What here getting like this, here also like this, here also like this. Okay. Energy and power signals. Consider V of t to be the voltage across the resistor or producing a current I of t. The instantaneous power P of t per ohm is defined as. Consider V of t, the voltage across the resistor. Okay. Resistor producing current I of t. This is the instantaneous power of t per ohm defined as at time power equal to V of t I of